I know some people are still in bad spell, so I'm gonna take this time to fix. Okay. Hey Stubby, hey everybody. Happy Wednesday. Happy day was restful and productive. It mostly was for me. It's getting warmer now, but it's also raining a lot more. So like, I feel like I should be going outside more often, but also that the weather is weathering. The weather is weathering a little, so it's like been raining. So yeah, I may order Taco Bell. But yeah, sorry I'm late. I had to take care of a couple things before stream started, and I sidetracked repeatedly. But we're here now. The high cap with high stubby, hi anybody that's lurking. It's Theo. Good to meet you. Today we're first game dev stream of March. Doing godot stuff. I decided, since this is the project that is the least risky to do this in, I was like, hey, it probably makes sense for me to try migrating viral core busters over to the new version of Godot that just came out. Only viral core busters, because if I do anything else, there is a non-zero chance that I literally would have exploded everything. And that's an important thing to not do with the game that you're developing. As a side note, the general rule of thumb, if your game engine has a major version update, right, it is usually best practice not to like go and like do a changeover like this. In my case, I did it most good. I just wanted to see if specifically there are things about Godot 4.4 that are more useful for us to potentially have a reason to do this. But I was like, thinking about it. So, one of the major things about Godot 4.4 that is very useful is that now, hold on, I guess it doesn't happen. It doesn't happen. God damn it. Y'all can't see it. Thank you. Hold on. Yeah, something's happening. Wait 1 second. Yeah, y'all can hear it, but y'all can't see it right now. I think it's like an internal video thing. I have an idea. First, that's it. still not quite working. Wouldn't surprise me if it just doesn't work. Yeah, it's a big thing. So you can't see it, but basically Godot recently integrated the ability to actually have when you're doing like scene testing, you can actually have it play in this window directly, as opposed to having it do a separate remote pop-up. So in this case, right, the part that is unfortunate about it not working here is that y'all can't see it, but it makes my debugging much easier because now I don't have to switch out of the big wide full screen window to be able to go look at this other thing, right? Oh, hold on. Okay, never mind. I did the equivalent of jiggling the wire a little bit, and sure. Cool. Awesome. Great. We did it. I jiggled the wire a little bit metaphorically, and somehow or another that actually fixed it. But yeah, the reason why this is much better from a development standpoint, from me personally, for example, is that now, right, if I need to like check something in the remote scene, I don't have to fumble back and forth between multiple windows in order to make stuff work. The only thing that I need to like solve now is getting the scale. So that's going to be the thing that we work on first today, especially because I showed up late. I'm going to sit down and go poke at the. I'm going to go poke at some HUD scaling stuff and then go from there. So yeah, one of the few things that like stealing from one of the few. Hang on, I'm joking. I'm joking like a little bit, but also not really. One of the things that makes sense to have stolen from Unity is this. Mostly because it makes your life a lot easier for if you need to like sort of look at the remote without having to fumble between two different things. And in this case, it means that now I no longer have I have one less window that shows up and fumbles up in front of what y'all are looking at if I'm using a project that's in Godot 4.4. If I'm not, whole different can of worms. But to quote to quote Saitama, that's tomorrow's problem for tomorrow's me. It's the simplest way to put it. Hang on a second. Right, I need to go look up the UI stuff. Okay, which means I need to open up my Godot tab. I have one of those. 7-minute video from someone who probably knows what they're talking about. Also, this is okay, viewports, multiple resolutions. Here we go. Okay, so we have the base size. That's already been set. Resize it. Okay, so I need to go into the project settings. So editor. Okay, so project settings. Let's go to. I know that y'all can't see the window for it. I'm messing around with stretch. Canvas items. Okay. So then let's see if that works. But how's everybody doing? Hopefully well. This either works amazingly or this is about to work real fucked up still. Okay, nope, that pretty much handled it. Alright, cool. Okay, cool. There we go. We fixed it. Hooray! Yippee! So, y'all remember how I was talking about screen resolution a while back, right? And how I was like, hey, so you want to design, when you're designing for a certain aspect ratio, you want to start at your largest resolution first and then work backward from, and then basically let whatever scaling solution you have then handle the downscaling. This is the reason why. So by default, right, 1920 by 1080 is the 1920 by 1080p. That's not right. 1920 by 1080 is the 1920 by 1080 is the actual pixel size that the game's base resolution is set to. In terms of what aspect ratio is, that is a part of the 16:9 aspect ratio, right? So 1600 by 900 is also included. To be clear, right? So 1920 by 1080 is like the next step up from 1600 by 900. And most displays nowadays, most of them are 1920 by 1080, right? So like most computer monitors that you get now are at that size, etc. So I started at that size first, right? And then I changed the setting in Godot that basically says, hey, scale these things down accordingly, right? So 1920 by 1080, between that and very specific anchors and other such things that I use to set up the way that the HUD works. So I'm going to pop over to the HUD for a second and show y'all what I mean, right? So when you look at the HUD, right, and you look at certain aspects of, for example, the player's info box, the anchor, this little green part, the anchor for the player info box is up here, right? Which means that no matter what scaling or resizing happens with the canvas, the player's info box, which includes the health bar and the player's portrait, right? That lives up in this corner. Even when it is resized or otherwise like changed about, it is anchored based in that corner. Similarly, the ready text that shows that little ready there, I pinned it to the center, right, of the HUD. So no matter how the HUD resizes or whatever, bam, stays right there in the center. Now, as far as this line view, right, for the actual like dialogue stuff, here's how it works. There is a big view control node that basically says, hey, this is the entire size of this view control node. The dialog box, though, is this big and it is anchored along the bottom. That's why the pins are stretched out to either corner and are out this far. So basically, right, even if the screen squishes upward a little bit or pulls downward a little bit, the dialog box will always be relative to that bottom edge. Similarly, the speaker name box, if you look at where the anchor is on the left side of the screen and a bit further down. So basically, even if the screen is stretched this way or pushed in that way, the actual speaker's name box stays like right there. This is why, generally speaking, when you are making a HUD in Godot, the best practice is usually to make sure that you have a control node for whatever thing that you want, and then you put other objects inside of it so that you can use the control node itself to determine where on the HUD it should be anchored and sit. Like I could have theoretically, right, had just the continue button sitting off on its own somewhere, right? I could have had the continue button without having it here, but then I wouldn't have had a way to be able to say, hey, wherever you put the continue button, it should be relative to this corner of the screen all the time, right? So it is generally good practice. It is generally good practice to make sure that you like pin those things accordingly. And so that's why, at least, and this is something that I learned from working on Shoot Lancer, because the Shoot Lancer, what happened was that we targeted, when we were doing like the HUD layout stuff, we targeted for the actual resolution. Specifically, I think we only did like 1280 by 7. I don't remember what we did exactly. But we didn't start out at the biggest size, which means that scaling up to 1920 by 1080 looks kind of funny when you try it that way, right? Because the form factor between, sorry y'all already know what time it is. It's time for the math lesson getting snuck in by accident again. Yippee! It always returns to math. I'm sorry, it just keeps happening. Okay. All right. I don't feel like going to get the stylus, so I'm not going to bother. But we're still going to do this. So, right? Well, actually, I should do it like this. Rather than dividing by 2, when I talk about like form factors in this case, I suppose what I should say is that if you ever want to know the ratio of how much bigger or smaller something is, right? Take the bigger number and divide it by the smaller one, and the result that you get is how many more times bigger than the bottom is the top. So if we do 1920 divided by 1600, the form factor is like 1.2. Or we could say that it's like 20%, or 6 so 1600 is 20% small. Right? So it's 20% small. So obviously, when you scale down to a certain extent, there may be like artifact, right? I hope I'm not being an absolute clown here. I'm gonna check some math and hope I'm not remembering this wrong. Yeah, so the form factor is like 1.2, right? And that's a point there. And I didn't make it big enough, so I'm going to come back over to the. That's supposed to be a point, and I just didn't. I didn't do it correctly. So 1.2, right? Or 1600 is 20% taller than 1920. In most games, that will not look too terrible, right? But the thing about computers, and this is the reason why, this is something that you may have heard if you had like a digital media class at some point in like the last 10, 15, 20 years, but there's a very good chance that you might not have, right? There's a very good chance that maybe this didn't happen, and so nobody explained this to you. But basically speaking, the reason why trying to make smaller things bigger when you're talking about images on computers, the reason why the more that you start trying to do that, the more like blasted out and gross the pixels look, is because when you do that, when you're trying to size up something that was already pretty small, the computer has to try to like make a guess vaguely at what the actual thing you were trying to do was. The computer in and of itself cannot figure out, it can't magically invent pixels where there weren't before. So it does a little bit of bullshitting, and then that's how things look more blurry when you try to size them up in really small sizes. On the other hand, right, when you size something down, generally speaking, you still lose information, but it's more so because the computer is like pressing it down more so than because it has to like make stuff up. So in a general sense, obviously there are certain adjustments that you have to make and everything like that. It is easier for a computer to interpret how to make an image 20% smaller than it is to make it 20% bigger. It is easier for a computer to figure out how to interpret how to make an image 50% smaller than 50% bigger. Because when it goes bigger from what it already was, it has to make up stuff to fill in the pixels that got added. When you are reducing a picture in size, right? And I mean in terms of like the literal dimensions of it, right? And you are physically shrinking it down, you're losing information as opposed to filling it in with random stuff, but you're not adding in information that wasn't already there. You're just trimming away some of the excess. So it's easier for that thing to retain its look and its shape when you are sizing down than it is when you are sizing up, if that makes any sense at all. So the end result of that is that, yeah, it is easier for the computer to take like a 20% reduction in size and make that look good than make a 20% increase in size look good for something that was already really small. Right? And that, I think, is the, if there is like, well, what's the reason why you want to start at like a high resolution then? Yeah, that's why, right? So granted, this does not mean that every single game that you make, you need to be like, I have to start at 1920 by 1080. Like, I'm not saying that, right? I'm saying, look at your aspect ratio. Decide what the largest aspect ratio you intend to support is, and then work backward. In this case, it is more convenient to start with 1920 by 1080 and work backward. That gives us more flexibility in terms of like getting things to size relatively on smaller screens than that. If this was something that I was aware of when we were developing Shoot Lancer, I would have said we're going to have to scale this UI to be at 1920 by 1080 and then work backwards. So that's the base resolution. And I would have said that earlier because it would have made things a lot easier in terms of like getting things to, I would have done that earlier because it would have been easier to get things to scale down without everything going horribly to shit. In terms of like making sure things fit and look good and all this other stuff. But, you know, oops. So yeah, we've done our honorary return to math for the stream. Let's kind of get back on it. Aside from that, so it turns out that I didn't immediately have moving platforms solved the way that I thought I did. I think they're okay now, but there's a pretty good chance that I might have still botched something. So we're gonna double check that and see. I was worried about a little bit of looking snapping. So this is the nice part now, right? Now I can actually go through this stuff and explain how this works without having to flip between a bunch of different things. So here's how this all works. Right? So we have a path region, right? Which determines the pathway that the platform follows. And if we come over to here, this curve, we can see that the curve has a couple different points, right? That's what all these are. These little position marks here are what dictate the path of the right? They sort of dictate the path of the way that this thing, right? The path follow 3D, on the other hand, is the actual object in and of itself, which is, so here's the way to look at it, right? Path follow 3D is basically like a proxy object that says, hey, whatever is a child of B, the path follow 3D will go along the path that's defined up here. So, with the path follow 3D, right? Inside of that, we have a platform. We have a platform node, which has a script for what it is. And then we have two things, a mesh instance and a collision shape. So the mesh instance is just what makes the platform look like the platform, and the collision shape is the actual body of the thing, right? And this is why, here's the critical part. This is why we need to have a path follow through. What's happening is the collision shape is being moved by the path follow. So if I were to pop back over here to the 3D view, let's actually look at the actual object of this thing, right? So you see here, right? I should come over here into the points and yeah, it's already closed. Cool. So here's the deal, right? If you look at this moving platform path, right, you see that we have this one, this one. So I think I can trash this one. Okay. I need to make sure that that is also, yeah, it should be fine. Okay, so if you look here, right, these points that are defined over here are shown over here as well, right? I can click on each one independently if I need to, but this is the, when you look at moving platform path, this is the path. So the path follow 3D then follows, right? So basically, the path follow 3D is something akin to a proxy object. So here's the thing. Here's where we get spicy. The platform is something called an animatable body 3D, right? And if we look at what the definition of an animatable body 3D is, according to Godot, it is a 3D physics body that cannot be moved by external forces. When moved manually, it affects other bodies in its path. So there's that. And then if we look at the actual script for the moving platform, we see that, and I'll comment these now. Hey Rachel, how you doing? I should probably change this to, because I realize that this is just like a safety thing. I'm gonna change this to match very quickly. Animatable body is what this should be. Node is fine, but really I want animatable body. That controls the position. On monsters, yeah, I just made it to HR10 last night. I'm finally out of low rank in Monster Hunter Wilds. Took me a minute, but I'm there now. So here's the thing, right? You know, if you need help finding parts, I don't have much in terms of the game of decorations. Absolutely. I have very many people who are like, actually don't forget to squat up, but I gotta like sit down and like look at what I need and then make decisions about how all that is set up before I start pulling people in for stuff. I gotta sort that out. But I do appreciate you letting me know. So basically, right, the progress of this thing is just move speed. And the reason why we do times float delta is to make sure that we're not going too fast, right? So here's the thing. I may have spoken about this earlier, but it's time to talk about something called frame dependent movement versus frame independent. It's very important. Cosmo time. How are y'all doing? Hopefully well. Good to see you in Cosmo. But yeah. So let's talk for a second about let's talk for a second about frame dependent movement versus frame independent. It's going to get a little wild, but bear with me, right? This is kind of important. Doing good, had therapy, but there's bright, shining things in mind life right now. We love to hear it. We do, in fact, love to hear it. So, okay. First of all, let me go save this thing. So. Okay, so let's talk about frame dependent movement versus frame independent. The simplest way to put it, this is something that you, if you've been playing a lot of video games, you may have already heard this come up at some point. But it is generally not a good idea in pretty much any video game ever to tie movement or other very specific things to your frame. Do not ever want it. And pretty much I can't think of any use cases off the top of my head where you want your frame rate to be frame rate. There's basically never a situation where that's the case. What do I mean by frame rate? So, here's the thing, right? So, as it says, I may not even need MS Paint, so I'm going to minimize it. You notice here, it says public override void process. And the notes here say, process is called every frame, and delta is the elapsed time since the previous frame. So here's the thing, right? When you say that a game runs at 60 FPS, 60 frames per second, right? What that really means is that you are trying to target 60 frames per second. In an ideal circumstance, that is the frame rate at which the game should be running. Based on the machine, based on the uptime, based on a lot of other factors, sometimes you get a little bit of a fluctuation, right? Maybe the frames will dip below 60, 59, 58, 55, right? If it's something like that, visually, most people will probably not notice if it's like a minor, right? But let's say that for whatever reason, right? Maybe you're playing on a machine that is really not equipped for the game that you're supposed to be playing at the settings, right? That starts making the engine, that starts making the thing jump. That's when, like, you start getting night posture and talking about that. I have to turn that off. Silly me. I'd be bothered to go find where the night bot thing is right now. I might as well do it. Okay. Right. So, frame stuff. Right. So when your frame rate, on the other hand, drops down to like 30 FPS or whatever, right? If certain systems in your game are frame dependent, then what will happen is that you are not accounting. This is the simplest way I can say it. If your game is like frame dependent, if I'm remembering this, right? I'm gonna go Google this real quick to make sure I'm not messing this up. There's a very good chance that I have this back. Okay, that's okay. So yeah, when your game is frame dependent, what happens is that you are not accounting for changes in frame rate due to like poor system performance or load or whatever, right? Which can cause very odd behaviors when a game is only updating. Like, let's put it like this, right? If a game is moving, if a game normally runs at 60 FPS, but hits like 30, and your movement, for example, is not frame independent, right? Then what happens is, despite the long lag in between the change of frames, if you're running at like 30 FPS for whatever reason, right? If your game is not doing like frame independent movement, for example, then something which moves will still move as if the game is going at 60 FPS even when it's at 30. And as you might imagine, that causes problems, right? Like shit starts blinking between spots that it shouldn't be, or going way faster than it should be, because the expected behavior, if you're programming in a frame dependent way, the expected behavior is like you're programming in the game thinking, oh yeah, I'm supposed to be running at 60 FPS, I'm gonna keep doing whatever. Meanwhile, the actual like you're actually running at 30, and the game and like your logic isn't accounting for that, so it starts like shooting things at like rocket ship speeds and all this other stuff in ways that you're like, I can't keep up with this. What am I supposed to do? Right? I saw some news that I'm not going to acknowledge. I'm going to put this over in another corner, and I'm going to not think about it. Because that's going to make me I like a lot. But, right, so with frame independent movement on the other hand, here's what's happening. And this is why times delta is. So here's the deal. I may have talked about this previously, but let's like get it. Delta, as it says here, is the elapsed time since the previous frame. And this is basically the way to think about it. This is the way that I explain it. Think of the frame rate of an application or animation or a movie as, okay, if anything animated is basically just a bunch of still images being rendered with minute changes between each one, sort of indicate how you're moving, right? Like if you've seen those old those old flip books where like you'll see somebody has drawn the picture a little bit differently each time on one of those pages, and then they like put their fingers through it, and it looks like it's actually animating. That is basically the principle of every form of animation ever, or any form of video ever. Anything that involves like video stuff like this is basically that, right? Images are being captured with their little differences between each other, and then being played back at a speed and a sequence that makes them look as if they're moving. That's basically the way that any form of animation works ever, right? You can think of the frame rate as how quickly you are thumbing through each of those pages. So the higher your frame rate is, the faster your thumb is going. When you are doing frame independent movement like this, you multiply some value by delta. Delta is basically a measure of how long was it between the last page and the next page that you flipped. In situations where your frame rate is lower, delta will be bigger. This also means that if the move speed is 5 and then your frame rate tanks a lot and your delta is huge, then what happens is the move speed that you are doing at 60 FPS gets multiplied by that big interval that happened because your game started slowing down. And so the end result is that the platform doesn't move as far when the FPS is lower, because the delta will be bigger when the FPS is lower. And what that means is, because it doesn't move as far, it's not like wildly overshooting the way that it's supposed to. There are basically, like I said, I'm not going to say there are none, because I maybe think there's maybe an edge case that I don't know of, but in a lot of games, in very many games, there are probably some where it doesn't matter this much, but in a lot of games, especially like action-based ones or things like that, you need frame-independent movement for exactly that reason. Because if the FPS goes down, you need to make sure that like whatever movements are happening on screen are taking into account fluctuations in FPS. That's pretty much the simplest way that I can explain frame-independent movement, why it matters. You do not want to be in a situation where you're like, yeah, I'm having this platform move at like 20 meters per second or whatever in my game engine, but then it's like, lol, Lamau, hey, guess what? I forgot to account for the fact that the FPS tanks at this particular point, so now this platform is moving at 20 frames per second. This platform is moving like 20 meters per frame or whatever, when my frame rate is like 30. Right? So, frame independent sounds weird, right? Because you hear frame independent and you think, then you're saying that regardless of frame rate. But when you think about it in the context of independent meaning, regardless of how many frames pass or don't pass, or how fast or slow they go, this object moves consistently. That's what's meant by frame independent. So yeah, that's the way that movement in this works. And if we were to look at the spy cloud, right? Spy cloud follows the same movement rules, right? Anything that moves in viral core busters follows this basic principle in some way or another, where it is accounting for any potential fluctuations or dips in frame rate, so that you're not having things like blink between positions. Like, even if your game is running at 60 FPS, constant, consistently, and you're like, I've never had any problems with performance, I don't need this, you still do. Reason for that is because, you think about it, this is the key part, right? If your game is running at 60 FPS, and you are not, this delta time will not be 0 when your game is running at 60 FPS, right? Delta time is always going to be some small, tiny little value, right? In an ideal situation, when your game is not like running slower than it needs to be, delta, and you're targeting, for example, 60 FPS, right? Targeting 60 FPS, your delta will always be approximately this value converted to decimal. It will always be about 1/60 converted into a decimal. It's some fluctuation because, again, you can't exactly always consistently forever nail 60 FPS all the time, even on a machine that's like great. It doesn't happen, right? It's not the way that it works. You're always going to get at least a little bit of fluctuation. Even in like stable system, it'll be like 59.1, 59.2, 59.5, 60, right? But it's so minuscule that most people won't notice. That said, though, you still need to account for delta with that, so that you're not going, again, like you're not going like 20 meters per frame every frame without controlling for how long has it been since the last picture show. So yeah, in a shell nut, that is how frame independent movement works. That is the whole thing behind it. That's the whole rationale behind how it works and why you should use it if you're making a game where stuff moves. If you're making a game where stuff moves around a lot, or is moved around, you should control for it that way, so that you're not sitting here going like, oh god, like I can't see shit. This is all kinds of fucked up. I can't. What is going on here, right? Okay, so something here is off. The tracking projectile is not doing this thing. I don't. Hang on a second. Something here is off. Okay, hold on. Something here's a little off. I don't know about that. So I'm gonna try something something different here. Okay. This is either going to work out great or it's going to work out terribly. So, what I'm trying to do here with this tracking, right? The idea behind the tracking projectile is that there we go. So there we go. Now it works. So the basic line of logic, right? Which honestly, then this means that I should do this. Really, if it's going to be more realistic, I should hop over here and do this because that's more accurate to what I actually want to do. And the projectile, it's just area 3D. Area 3D doesn't have anything going on in this base physics process. So we can get rid of that. Doesn't matter. This one right now. me go back and explain this logically. So actually, I can simplify this even further because I don't really even need this. I could just do this, and then do this, and then we're good. So let me explain the way that this works. So the tracking projectile, if we have a target, then our direction is calculated by taking its position and subtracting ours. Sorry, I should say if this projectile has a target. The direction is calculated by taking its position, taking target's position, and subtracting ours. I'm going to wait for the app to finish before I go back in on the thing. So while that's going, I'm going to do something else. Actually, while this is going, ouch. Um, so let's talk. I was talking about direction. Okay, right. So, basically speaking, right, in order to track basic direction, there are other ways to do this, or something akin to this, right, with Pathfinder and stuff, but we don't need all of it, right? Like, that's a little too much math. The only math we really need is basically, so, basically, right, direction is sort of, it is like a derivative of finding the distance. It's always math. Direction, and I've said this in a previous stream before, but I'm just going over it again because I know there's some people that have been this and maybe don't understand what it, but I could. So, yeah. Here. Okay. Cool. Okay. So, the distance formula is usually like square root. Hang on a second. Let me finish up the brackets. Yeah, I already messed this up. I'm doing this wrong. Thinking about it. So, I'm already thinking about this wrong. My brain is. Direction. Basically speaking, direction in 2D games, right? Or direction finder. In both 2D and 3D games, it's pretty straightforward, right? Really, all you're doing is finding this slope. So, right? Basically speaking, right? So, slope is normally y2 minus y1 over x2 minus x1, right? So, 2 is destination, or second point. 1 is start first, right? So if you remember anything about like graphs from school, like Cartesian graphs, 4 quadrants and all that other stuff, finding the slope is basically this, right? So where 2 is the destination, the second point, and 1 is the start or the first, right? So here's, if you're finding direction, right, you don't have to do division, you just have to basically do here's the way I turn this. You are still working technically with something like this, but you are treating 2 and 1 as distinct points, right? Or rather, you're treating them as a unit. So we'll take these two, right? that becomes P2 or 0.2. These two, I should do it. I realized that. So these two become 0.2, and these two become 0.1, which means that you can then translate this to, if you do 0.2 minus 0.1, get a direction. Or rather, you get the direction to 0.2. Get the direction to 0.2. This is pretty much the way that it works, right? That's why I said it's similar to finding the slope. Slope is y2 minus y1 or x2 minus x1, right? That tells you the rate of change for the actual line, right? In this case, though, if we were to take y2 and x2 and combine them into something called a point and treat that as 0.2, and y1 and x1 into another point, which is 0.1, where 0.2, P2, is the destination point you're going to, and P1 is the start point, and P2 minus P1, and the same that like y2 minus y1 and x2 minus x1. P2 minus P1 is just the direction to point number 2. And that's what this part is, right? We take the target's position and subtract. So the target's position is our P2, our own position is our P1, and I use the global position here so that we're taking it relative to wherever it is on the screen, right? And now, here's where I bring in a little bit of physics. I'm sorry. Getting weird, right? Reason why we call it direction, and the reason why we normalize it here, right? I should minimize this. So the reason why it says dot normalized here, the tooltip for it says returns the vector scale to unit length, blah, blah, blah. You might be wondering, like, what the heck is that? First, let me save this one, and then I'm going to do another MS Paint. So again, this is simple direction finding. There are more complicated and complex ways to do what's called pathfinding behavior, where between any two given points, if you lay down something called a navigation mesh, right? So let me put it like this, right? Direction finding uses this in like MMOs and stuff like that, but then in order to make sure that you're not like clipping through the ground and shit, they also use something called a navigation mesh, which sort of determines the topology of the environment that you're walking over, as well as something called a pathfinding algorithm to give you, generally speaking, the shortest point between this and this using the nodes on the pathfinding mesh, on the navigation mesh to get you there. But that's a whole other can of worms that we're not getting. This is simple direction finding. We don't have to worry about like that kind of shit, and it's just like I need to know how to get there, here to here, and it's fine if it moves in like a roughly straight line because I'm not anticipating that X, Y, Z. Like I said, MMOs and other like games where it's like you can click on a thing and automatically move toward that thing, they use this plus a bunch of other shit to make it work right. So we're not talking about that. We're just talking about very basic direction finding. Now, in terms of normalizing, and what does it mean to normalize, right? So, when you normalize the value, right? The general idea is that you take whatever result that you get and you scale it down to be expressed as something between 0 and 1. I've talked about this before in developing viral core busters when it came to health, right? So basically think of normalizing values is hey Shiny, expressing values as a 0 to 1 ratio. Basically, this is what normalization is. When you're normalizing a value, you're basically expressing it as a ratio between 0 and 1 functions, right? And if you can express something as a ratio between 0 and 1, you can express it as a percentage between 0 and 100. That's like a whole thing. So that's an example, right? So health percents, right? I don't remember which way you write sentences. This way. So using it as an example, right? Health percentages in games, right? I swear I can find it. So, for example, normalize health in games, or the health percentage, right? All you really do is you take your current health divided by your max health, and whatever you get back is the normalized value, right? So, for example, right? One, 4, 0.25, right? 2, 4, 0.5, etc. Right? So, the reason why we would want to normalize directions, so normalizing health values makes sense, right? Because now you can do a thing, and I talked about this previously with the health bar, so I'm going to go demonstrate this first in Godot. So if we go and look at the HUD, for example, right? And we look over here at the player's health bar in the HUD in Godot, right? So we come over to the HUD so we've done that. If we look over here, right? Look at the player health node. Minimum value is 0. Maximum value is 1, right? So between 0 and 1. Step is how big, right? How big are the increments on this particular health bar? We said 0.01 so that we get like a nice, if we need to, we can animate a nice smooth transition, right? But you sort of see what I'm already getting at, right? In a situation like this, where we say there's a health bar, because rather than having to try to figure out, okay, well, what if the max health upgrades from 4 to 5, or 5 to 6, or 6 to 7, right? Then we would have to come and adjust the maximum value every time to accommodate. We don't want to do that. That's annoying. What we do instead is, by getting the current health value as a normalized value, so even if for whatever reason the max health increases, maybe like a power up, right? It will change the value that we get back, but the logic is still going to keep it between 0 and 1, right? So let's say the max health got bumped up to 6. So these are examples where max health is 4, right? max health. I'm gonna get better at this. Health 6 on the 2 out of 6 is, 0.3. 3 out of 6 is still 0.5, right? 4 out of 6 is 0.6, right? All that other stuff. I swear I get it. Right? And all that other stuff. Well, right? But the main point is that these are all values, you notice, that are still stuck between 0 and 1. Right? And so that means that as long as we are reporting to the health bar what the normalized health value, right? As long as we express to the health bar normalized health value is, we will always, without having to change what the max value is programmatically over here, we will always be able to control the way that the health is output without having to do a bunch of output, right? The reason why this matters for directions is because, going back to physics for a second, right? A direction plus a speed gives a velocity. So, what we are doing when we are moving an object around in Godot, right? We are, functionally speaking, we're deciding what its velocity is, for lack of a better term. We are deciding, right, how fast it goes over time and in what direction. So, for this purpose, a direction should not exceed, it should be somewhere between 0 and 1. But the direction itself should not have a super, let me phrase this carefully. If we were to leave these values unnormalized, what would happen is, so you see how it says here, targeting hurt box in the direction 0, this negative 0.38, this negative 0.92, right? I can look at that and know off the top of my head, okay, so the projectile is basically moving this way. It's moving down and to the left, right? Now, if I didn't normalize this value, it would probably be saying something like maybe negative 10 and negative 50 or something, right? And it's like, okay, I can still read that. But the problem comes in when we then set up that velocity. What happens is, it would be something like negative 10 times 50. So I'm going to demonstrate by taking out the normalized one. I think if I take this part out, it's going to demonstrate for y'all why we want to normalize this. If you don't normalize this value, bad things happen. Y'all are going to see what I mean in a minute. And I'm going to uncomment this here so y'all can see. Because I realize that it's like I can talk about it all I want, but trade it, it's going to be far more effective. See how fast it's moving, right? That projectile. You see how fast it's moving, right? And that's why we want to normalize it. Because what's happening is, if we go and we look over here, now we see, right? Oh, it's negative 3 and negative 6. Which means that the speed of the projectile is then being multiplied by negative 3 in order to not only give it the spacing that it wants, but then it increases the speed because that number is not between 0 and 1. You understand? You see what I'm saying? Right? You see what I'm saying, right? Where if we don't normalize that value, what happens is the direction winds up having an undue influence on the actual speed of the projectile. in terms of how quickly it travels. We still want there to be an influence in terms of what direction it's going, but we don't want it to be outsized. We want to make sure that we get that value normalized so that what happens is, rather than getting like an extra boost of like -3, maybe we get only like an extra boost of like -0.3, whatever, right? It keeps the projectile from moving too fast. And it also keeps it moving in the direction that it's supposed to be moving. Right? And if we want it to be really specific, we can do this even to make sure. Well, I should do it like this, honestly. If we want to be absolutely sure that we're only messing with the projectile speed with float delta, then we do this. Right? But as it says here, so yeah, right? If we want to be absolutely sure that we're only messing with the projectile speed with float delta, then we can do it. But that's the main point, right? By normalizing the value of the uh, of the direction, we are making sure that basically at most our direction can be one of our direction in either the x or the y. It's basically somewhere between -1 and 1. And that's the way that we want it. -1 and 1 is the way that we want it, because we don't want the simple act of firing in a different direction or firing at an enemy that's farther away from you to make it move faster. Do not want that. It's not the way that we want to do it. Now, well, at least for the behavior that I want. If you want that behavior, right, then maybe you don't normalize the value, but then you find some other way to adjust it as you get closer in some other form. You feel me? So when I say that, right, what I mean is the reason why we normalize values for the directions in particular is because we only want to get a value between -1 and 1, so that the speed is mostly moderately modified by the direction that we're going in, and it's more so which way it's going that has the stronger influence than how far away the enemy is or how far away the target is. That's the reason why we do that. It also just makes it easier to read because I can look at like -0.35. Well, easier to read is debatable, I guess, but my main point being is that for the purposes of making sure that we don't shoot faster at an enemy that's farther away, we want to normalize that. Basically, the simplest way to explain it. So now, right, now that we've done this, so I can, for example, now come over to here and I can do this, right? Now, if I change the projectile speed, right, it's going to it's going to go fast. We're just going to replace that magic variable with like that magic number with an actual variable, so that when it comes down to it, we can say this is how long you need to wait for all that. Right? So now I save this and I come back over here and I rebuild the project real quick. Right? Now, if I need to, I can change the speed of the projectile, the move speed, the firing delay, all that other stuff I can do here, propagate that through the actual script, and those things will follow through. I also just got a silly ass idea that will probably make playing Koro at least a little bit easier. I'm gonna try it, and if I don't like it, then yeah, I like that. That's better. That's already better. I like that much better. Okay, I'm gonna go do something silly. I gotta check one thing real quick because I forgot what potion you corrected this. Okay, so projectile. Okay. So here's what I'm doing here. I keep forgetting to minimize. So here's what I'm doing here that I think is going to be silly, but that I think is good. So for horror, you'll notice that on the attack box and the dash attack, look over here on the side where the inspector is. Click on collision. We have layers. We have masks. So layer, for anything that has a collision object 3D like this, layer tells you what layer it's on. Mask tells you which things it can touch. Right? In this case, right, I'm saying that all projectiles live on that projectile. Which projectiles they then belong to are determined by what group. Enemy projectiles are in the group enemy group. Player projectiles are in the group player. So, if I did this correctly, the logic should be that if Koro swings and attacks a projectile, he should be able to destroy it. If I did this correctly. There's a pretty good chance that I didn't and that I messed it up, and I'm going to cry. And look a little messy in these chocolates. Cool. It works. With one error. Okay, cool. So then this means I want to do this back. I want to do this logic back. So, in Koro's case, basically what's going to happen is, first we're going to check if the other node is in this group. And if it's not, then we'll do these two, right? And the reason why we're rearranging it is because, basically speaking, if the other node, if whatever thing that Koro swings at, right? If it's in that group, then it triggers that thing. If it doesn't, then it won't. And as long as we are careful about making sure that we don't set for example, the reason why it doesn't go off when Koro swings at a wall. The reason why it doesn't go off when Koro swings at a wall, for example, is because he's not set up to detect walls. Okay, cool. Got it. That works pretty well, actually. Okay, I like that. In fact, I like that enough that I'm gonna try that projectile collision type stuff in this actual other thing over here. So let's see. If I remember this correctly. Okay, so here's where I really want to be careful. So, notice over here that I said projectile, add to group, node groups, player projectiles to show, right? This is fine. However, here's what I want to do instead. I want to make sure that projectiles have their own way of being added to groups. So I'm going to do this. Public void set node groups new set. I'm going to call this actually set projectile. Set projectile, right? And then add group, right? And now we're going to do a switch statement. If it's player projectiles, we're going to say flash node group equals node groups dot basically we're going to do this, right? So basically, player projectiles clash with enemy projectiles clash with player, right? Nice and simple. So what we're going to do here, right? I'm going through the code and setting it up so that the projectile group is only set by doing set projectile. That's the only way in which we want to do this. We no longer want to do a thing where we no longer want to do it where we do it like this for projectile, specifically because we want to make sure that we set the clash node group automatically based on what group we're switching. Based on what group we're setting to. So if we're setting up a projectile as a player projectile, right, then it clashes with enemy projectiles and vice versa. Makes our lives a lot easier, so you don't have to like think. And now we can do the same thing over here, right? So now, whenever we are setting projectile groups, this is the only way in which we are doing it, by using this function, set projectile. And the reason why I am doing it that way is because with functions, right? I said this before, but I'll say it again. The main purpose of using a function in programming is to take a task that you do repeatedly, right? take a task that you would do repeatedly and basically you take wow, my brain I just wrote. One second, right? You take a function. With a function, you take a line of code that you use like 3, 5, 7, 9 times in multiple places, and rather than putting yourself in the position of I broke something with this. Hang on. The spy cloud's not shooting, which means I broke something else. Okay, hold on. Okay, let's take a look. There we go. So yeah, as you can see, right, I swing and that gets this, right? But basically speaking, right, functions and repeating and like doing, just automating like things that you would like normally use repeatedly, right? Rather than having to like go and set up a thing every time where I have to go, okay, now I gotta, for every single time I put an enemy projectile in there, I have to make sure I set this other route. No, right? I can just set it up such that it's like, hey, if you are a player projectile, you clash with enemy projectiles. If you're an enemy projectile, you clash with player projectiles. Just whenever I tell you to join this group, do that. Right? It's a matter of lessening the amount of time you have to spend duplicating code. Duplicating code is not always a bad thing. Let me be clear about that. There's times and situations where you don't have a choice sometimes but to duplicate code, and that is fine. Right? But if you are in a situation where, and this is something that comes with practice really more so than anything else, you're in a situation where you have figured out how to tell the machine, hey, here's the thing that I need you to do. The thing that I need you to do is when this rule happens, do this, right? Once you have that sorted out, and once you know how to tell the computer how to do that thing, there is no reason to manually go through and tell it every time. If you are using functions wisely, that is the trouble that they see. So in fact, I'm going to comment this right now. Adds the projectile to a specific node group and automatically determines what nodes it clashes with. New group, new node group set to convert the new group into a switch statement. Player projectiles only flash. right? Any projectile only clash with player, right? If I wanted to get more in depth with this, right? Or we can even take it one step further. I'm probably thinking a little bit too far ahead in the future, but maybe future me will be grateful for this. So peep this. We can still use this code. We just have to adjust it. So here's what we're going to do. Each take this, drop it off in here. We're going to get one more fuss in one more spot. All right, cool. So we can do this. And the reason why I would do this in theory is because if there is a situation where I want to make it so that multiple objects, right? Like if I wanted to move, for example, so here's what I'm going to do, right? I'm just going to do it like this because I can even make it more one-sided, right? So I can come over here now and I can just even get rid of this, right? Now I don't have to worry about it at all, right? If the other area has all this other stuff, that's fine, right? What I can do now, if I'm careful, is let me double check here and see where. So no, actually, I'm not going to. I'm gonna not get too wild. I'm not gonna get too froggy. I'm gonna just do it like this for now. So for right now, I'm gonna still leave this the way that it is. And I'm just going to have it so that specifically Koro's hitbox specifically erases it separately just for safety. Just for safety's sake, right? Um, okay, brain is not braining, which means that we're probably running close. Because usually when my brain stops braining, that usually means that it's almost time. I'm gonna come over here and we're gonna just test one last thing. Level manager, we're gonna switch over to funk and then to voke, and then we're just gonna see and make sure that this projectile erasure works the way that I would like it to. Ah, dang it. Hang on. Forgot to do that. That should fix that. Sometimes, and I forget this, with certain types of variables, you have to actually make like a new thing of that variable before Okay. I think that should fix it. Basically speaking, that no reference exception that it says no reference exception here because I forgot to make sure that we even have like an array to hold before we do. It's kind of the equivalent of saying, there we go. You may notice that like I shot the projectile and it went straight through, right? You might be going, well, why is that? That's weird. And it's because, very simply, right, I have to come over here, come over to the collision, and make sure that these things are set up. So I do have to set, for example. So I'm going to make sure that projectiles can, for example, clash with each other. That's the main part that I forgot, right? So where it says mask, right? The mask is what determines what this thing can. So for the walk, for the rogue projectile, the spy cloud projectile, the player projectile, right? Like a lot of this is all stuff where it's like I have to make sure that those things are set up to clash with each other, or it's like they don't see each other. So because I didn't set the mask, that's why I was like, lol, I'm out, nothing's happening. But it should work. And that's projectile CS line 128. So line 128. Okay. I think this should also make it so that that stops happening. Break. Okay, I think that should fix that. I think I should be able. The reason why I was like getting upset and giving me the error anyway is because what would happen is it would break out of for each loop for checking if there was a clash, and then it would go and try to do the check. I think if I do a return there instead of I do return instead of break, and I think it should fix that. Yep, got it. And now this means if we do Voke as well, you should get similar results. It'll be harder with, we're about to get ads in a minute. It'll be harder with Voke because her shots do tracking stuff, but it should still work about the same. Okay. So, oh, it's because it's probably okay. I see. I see. I see. Something that I messed up. I changed something about the way the spy cloud is laid out, so it's not working. Okay. Okay. So, at all. It's the worst thing. Yeah, I can't test projectile flashing with both because hers don't curve. But now we're running into a different problem. I think. So I will have to figure that out. But for now, it is time for us to skedaddle. All right. Appreciate y'all. Thank y'all for hanging out. We're out of here. We got some other stuff to be doing. So we're gonna go be doing. Let's see. So. Game analysis, design articles are over on Munity blog. Stream pops up on YouTube. Ko-Fi, if you want to support the game stream, give money to Amazon and Jeff Bezos. Ko-Fi's preferred. Drone, do anonymous gift giving for me over there that you are very strongly feelings about. And the card is on my social media links, including my if you want to know more about the game dev videos that I helped profile, you can go check out munity.games. That's like community without the COM in it. Our Patreon has a free tier and a paid tier that you can join to hear more about what we're up to and things like that. And then if you want to play a demo of our game Shoot Manager, you can head over to that link. And then last but not least, if you want to hang out with us whenever we're not live, I am mostly on Guilded. That is where I hang out. That's where I do stuff. I don't rock with Discord for this community personally, for several reasons. You are required to make a Roblox account. You can literally make a Roblox account and then never use anything ever again. But if you don't want to do that, I understand. Plans. Friday is this Friday. I'm not really sure what I'm going to do yet, but it's going to involve I don't know what. I'll figure out what that is when it is when it's time for that. And that'll be whenever that is. I'm not stressing. It could be Grand Blue versus Rising. It could be something else that we can about. Sunday, 5 p.m. Eastern Time will be whatever game we're picking up in lieu of. Well, it might. So the short answer is that I am going to be traveling, not next week, but the week after. So, like, we'll have time for a stream on the 16th, but I'm not sure if I'll be back home. I have to double check. I think I'm coming back on the 23rd or like shortly before then, so I may not have the strength up to stream on the 23rd. We'll see about it. So I'm debating if I want to start something right now, knowing that I'm going to have to take a break, probably on the 23rd or not. I'm thinking of it. I'll figure it out. But I'll make that decision closer to. So, who are we gonna go ahead? Because it went to the next level. So let's see. All right. Twitch.tv. I don't think we can go to. I feel like we've been to Formangander recently. I feel like we've been to Formangander at some point recently. I just cannot remember. I want to go hang out with Formangander. I feel like we've been to them at some point recently, and I cannot remember when that was. And it's itching my brain really bad. We might just go do it anyway because fuck it, we ball. Yeah. I think we're gonna go hang out with Formangander. Turns out I doubled up at some point. My bad. So Formangander, they play a variety of games, usually with like weird and odd steering apparatus or control apparatus, like steering wheels and stuff like that, or Donkey Kong bongos. But at the moment, they are currently playing some Monster Hunter Wilds. They are HR66, so they are post-game. If you do not want spoilers for Monster Hunter Wilds, you may not want to come on this video. But they are Hunter rank 66, which means that they've cleared the main story and have probably gotten at least some of the way into a lot of the hunts that come afterward. If you do not want spoilers for Monster Hunter Wilds, you may not want to come on this video. So when you get to the form and give them an SPH, that's great! Let them know I sent you, throw in your favorite emails. They don't have to be money. Whatever. Until next time I see y'all, whenever this is. Stay safe, wash your hands, wear a mask, don't go outside, don't have to be exes. Not bigots, racist, terrorists, sexists, anti-queer folks, or fascists. Remember, Black Lives Matter, trans rights, effective rights. Palestine and Sudan, the Congo, New Caledonia must all be free. None of us are free until we're all free. If by some chance you are like, don't know what to do, if you're not sure how to make a change, how to support whatever is going on in the world that we got going on right now, pick one issue, even if it's like local to you. Pick one issue, even if it's like local to you, right? And that's your issue. Do what you can, and even if you can't do that much, if you are doing what you can to support people around you that you know in whatever way that you can, it doesn't always do it, right? Then you're doing what you can. That's it. Alright, y'all. That's all I've got. Let's go hang out with Formangander. Deuces. Until next time, whenever that is. Take care.